Hello, this is Mrs. Johnson. This is Calc 3, Section 9.1. I'm going to be going through a couple of examples here from the PowerPoint. Now, a familiar formula for the distance between 2 points in a plane, which is, remember, called the distance formula from Euclidean geometry, can easily be extended into 3 space to find the distance between 2 points in 3 dimensions. Here's the distance formula for 3 dimensions. The distance between points P1 and point P2. This is called the absolute value because remember, distance is always a positive value. Between any 2 points where P1 is given here and P2 is given here is simply an extension of our old our old distance formula. Also, the equation of a circle can then be extended to 3 space to find the equation of a sphere with a radius of r and a center at the point HKL. By definition, a sphere is the set of all points whose distance from P to C is the radius r. Thus, P is on the sphere if and only if the distance between P and C is equal to the radius. Squaring both sides of our formula here, we get the absolute value of the length of PC squared is equal to r squared, or we have this extended formula. This is our equation for a sphere in 3 space, where H, K, and L is the center of the sphere, and R is the radius of the sphere. And here's our equation. Notice if the sphere is centered at the origin, we simply have H, K, and L are 0, so we get this formula. Now this looks very familiar to us, very similar to the equation of a circle. All right, so let's try a couple of examples. Find the lengths of the sides of a triangle ABC. Now remember, if I want to find the lengths of each side of this triangle, I simply find the length from A to B, the length from B to C, and the length from A to C. Using our equation for the distance between 2 points, we get the length of AB is radical 35, and we can leave it just like that. The length of BC, again, putting it into our formula, we're subtracting, we're doing B minus C here in our points. We're plugging in, we get is radical 136, and the length of AC is equal to radical 67. Here's my 3 lengths of my sides of the triangle formed by these 3 points in 3 space.